On December 19th, 2025, our planet made a really strange and very precise sound.
Scientists picked up this mysterious signal, a sharp spike totally unlike Earth's normal background hum.
And get this, it was locked at exactly 25 Hz, a frequency that just shouldn't be there.
So what was it, an equipment glitch? A secret message? Let's figure this out.
The first clue actually showed up 11 days before we even detected the signal.
A massive earthquake, a planetary scream, and an interstellar visitor. All of it timed perfectly.
This visitor wasn't an alien ship, and it was so far away, its gravity was basically zero.
So how could a distant rock affect us so precisely? Well, it turns out it's not gravity.
It's electromagnetism. Think of it like a cosmic highway for energy, connecting everything.
Okay, but how does Earth talk back? The secret is actually buried deep in its rocks.
When tectonic plates get stressed, the quartz inside literally creates an electrical signal.
And this isn't just theory. In the lab, rocks broadcast these signals right before they break. We know this signal also appeared before the Japan quake. But was the flyby just a coincidence?
When AIs analyzed it, the signal was unique, way more precise than any natural or man-made noise.
This leads us to the trigger hypothesis, all based on a cool concept called metastability.
Right. Think of an avalanche. A single shout doesn't cause it, it just triggers it.
So the rock didn't cause the scream. It just pulled the trigger on a system already loaded.
But if this was a message from Earth, who is it for?
This last clue is a wild one.
Turns out, 25 Hz is right in our beta brainwave range, the one for alertness and anxiety.
So could Earth's scream actually cause a worldwide wave of unexplained tension? It's possible.
But this opens up a whole new field, precursor science. We could predict quakes by listening in. It's a powerful reminder. In a connected universe, we just need to learn how to listen.
Okay, let's just jump right in. Imagine the Earth. For billions of years, it's been humming along with a pretty predictable low-frequency tune. You know, it's a chorus made up of lightning strikes all over the globe, the constant thrum of our power grids, and that sort of rhythmic breath of the Schumann resonances. Then, all of a sudden, on a freezing morning in Siberia, a new sound cuts through all of that noise. And it was completely unexpected. It wasn't atmospheric static, it wasn't a satellite passing overhead, and it definitely wasn't some kind of power line fault. No, it was this precise narrowband spike locked with just an impossible stability at exactly 25 Hz. It wasn't a whisper, it was, as the first quartz described it, a planetary scream.
And that scream, it's the whole reason we're doing this deep dive. It was detected at the Tomsk Space Observing System in Siberia at 02.40 UTC, December 19th, 2025. And it represents a fundamental challenge to how we view our home planet. This is all about the 25 Hz convergence. We're talking about a truly remarkable celestial and terrestrial coincidence that, frankly, it just defies statistical probability. You have events separated by vast distances, millions of kilometers in space, and hundreds of gigapascals of pressure deep in the crust. And they all synchronize on one single precise frequency.
It feels like we're moving past the idea of Earth being this simple, solid rock. For so long, the conventional model was that Earth was an isolated system, driven only by its internal geology, magma, convection, the occasional gravitational tug from the moon. That idea that Earth is basically decoupled from space, well, it essentially collapsed on that day.
It did. And our mission for you as you listen is to synthesize the massive amount of data that was generated during this period. We're pulling from global electromagnetic monitoring, deep astrophysics, geophysics, and even biophysics to really understand what happened when the Earth seemed to, speak at this specific anomalous frequency. And this isn't just theory. We're synthesizing hard-won data from dozens of sources, spectral analysis of the signal's purity, complex post-event seismic modeling, and the precise trajectory calculations of our interstellar visitor.
And the reason this whole event is so scientifically magnetic, and let's be honest, so insane, is what the source material calls the coincidence of three. These are the three linked factors that happen either at the same time or right after each other that we absolutely have to explain. First, there's the precise, high-purity 25 Hz electromagnetic signal detected in Tomsk.
Second, the point of closest approach, or what astronomers call perigee, of the interstellar object 3I Atlas. And that happened just 3 hours and 20 minutes after the signal was recorded in Siberia.
And this is the critical third factor. The preceding magnitude 7.6 earthquake that devastated parts of Japan 11 days earlier on December 8, 2025. Post-analysis, and this is the picker, revealed that the exact same 25 hertz frequency was present as a stable precursor in the electromagnetic data leading up to that massive seismic rupture.
So right there you have a terrestrial signal, a preceding stress event, and a cosmic visitor all syncing up. It's incredible. What's so fascinating here is that the signal implies what physicists call a threshold event. It forces us to pivot, really fundamentally, from our standard models that rely almost solely on gravity and mass to these new concepts of electromagnetic coupling and planetary resonance.
Resonance is absolutely the key word, isn't it? Yeah. It suggests the Earth wasn't just like hit by a cosmic hammer. It's more like a gentle, precisely tuned vibration caused a tightly wound system to just release all this pent-up energy.
Absolutely. We have to start viewing the Earth not as a dense, inert solid, but as a high-Q resonant cavity embedded in this complex magnetic web that fills the solar system.
Okay, high-Q resonator. Break that down for us.
Well, think of a really finely tuned church bell or a crystal goblet. It holds onto energy very, very well. That's high Q. When you strike it, it rings clearly for a long time. Because it holds energy so efficiently, even a weak, precisely tuned input, if it matches the system's own instability, can cause a disproportionate massive release of energy. That's the nonlinear dynamic that's essential to understanding this entire narrative. The system was metastable, it was charged, and it was just waiting for the smallest touch.
Okay, so let's start with that touch then, the cosmic trigger. Our uninvited guest, 3I Atlas. We really need to set the cosmic context for everything that happened next, because without this interstellar object, that 25 hertz signal would probably have been just dismissed as a fluke?
Right. 3I Atlas was first spotted back in July of 2025, and its confirmation was a huge event in the astronomy community. It marked only the third time we've ever confirmed a macroscopic object entering our solar system from interstellar space. It follows the path blazed by 1I Amora back in 2017.
Ah, yes. The weird, rocky, cigar-shaped enigma that nobody could quite figure out.
That's the one. And then 2I Borisov in 2019, which was a bit more of a classical rogue comet. Had a nice tail, behaved as expected.
So 3I Atlas is part of a very, very exclusive club of galactic wanderers. What was it that confirmed its alien status, so to speak?
It's an astronomical feature called its hyperbolic excess velocity. Now that sounds like a lot of jargon, but it's actually critical. Most objects in our solar system, planets, asteroids, comets, they follow these elliptical orbits. Their eccentricity is a number between 0 and 1. They're gravitationally bound to the sun. 3 Atlas, just like its predecessors, had an eccentricity significantly greater than 1.
Which is the very technical way of saying it has way too much speed to be captured by the sun's gravity. It was just passing through.
Precisely. This confirms it was ejected, likely millions or even billions of years ago, from a star system far, far away. It was wandering the galactic void until our sun's gravity, just happened to intercept its path. It was a tourist, basically, traveling at interstellar speeds.
Now, here is the giant roadblock that completely stumped classical geophysicists, and the source material really spends a lot of time on this point. When 3I Atlas reached its perigee, its closest approach on December 19, it was still an astronomical distance away from us. 1.8 astronomical units, or roughly 270 million kilometers from Earth.
And this point cannot be stressed enough. The gravitational influence of 3I Atlas at 1.8 AU was absolutely negligible, just nothing. Gravity diminishes rapidly with distance by the inverse square of the distance. At 270 million kilometers, its pull on the Earth's crust was far, far too weak to physically pull on the planet or generate the kind of tectonic stress you'd need for any kind of measurable signal.
So if we're only looking at this through the lens of gravity, this entire correlation has to be dismissed as pure random coincidence, which tells us we must be looking for a different mechanism entirely.
Correct. And this is where it gets really, really interesting. The interaction, it must be electromagnetic. Yeah. We have to fundamentally stop thinking of space as a vacuum. It isn't. We have to start thinking of it as a conductive plasma medium. Space is filled with the solar wind, which is a supersonic stream of charged particles flowing constantly outward from the sun.
So our whole solar system is essentially swimming in this highly dynamic, charged environment.
Exactly. And the key to this whole thing lies in the physics of the plasma wake. When a solid object, even one made mostly of ice and rock and dust like 3I Atlas, moves at these tremendous interstellar velocities through the solar wind plasma, it's like a superfast ship moving through water. It generates an immense displacement.
Right, it doesn't just cut through the water cleanly, it creates a massive disturbance, a wake.
It creates a bow shock where the solar wind slams into the object and then a powerful turbulent plasma wake trailing behind it for millions of kilometers. This wake is highly charged and it's structured. Critically, this structure interacts violently with the interplanetary magnetic field, the IMF, which is the sun's magnetic field lines that permeate the entire solar system.
So the object isn't just floating inertly through space. It's actively pushing this gigantic turbulent magnetic wave in front of it and dragging a long charged tail behind it.
And that turbulence, that's the mechanism for energy transfer. The interaction with the IMF perturbs the field lines, and that generates what are called alpha waves. These are a special type of magnetohydrodynamic wave that can propagate incredibly efficiently along magnetic field lines. The source material really emphasizes a key insight from space physics here. If the Earth crossed this wake, or the magnetic field lines somehow connected the object's environment directly to ours, a process we call magnetic reconnection, then the transfer of energy in the form of an electromagnetic perturbation becomes remarkably efficient, even over 1.8 AU.
Okay, wait, I need to pause on that conceptual leap for a second. You are telling me that 270 million kilometers is effectively irrelevant if we are linked by the same magnetic highway.
That is precisely the implication. In electromagnetism, distance is often less of a factor than connectivity. The alpha waves generated by 3 Atlas's passage could have essentially wrung the magnetic field lines that are connected to Earth's magnetosphere, like plucking a guitar string. This is an energy transfer mediated not by mass, but by field and by charge. The detection of the 25 Hz signal forces us to acknowledge that Earth is coupled to these vast structures in space.
Before we go any further, we absolutely have to address the elephant in the room, the skepticism and, of course, the question of a technosignature. Every single time one of these interstellar visitors shows up, the internet just explodes with questions about alien involvement.
And scientific rigor demands we address that head-on. And, following the precedents set by Oumuamua, there was intense speculation. It was a weird object. Consequently, major initiatives like the Breakthrough Listen Project and the Allen Telescope Array dedicated significant resources to observing 3I Atlas. They conducted exhaustive surveys, specifically looking for any kind of artificial narrowband radio transmissions across the 1 to 9 gigahertz range. That's the typical spectrum you'd look at for communications.
And the results were clean.
Completely clean. Zero. No structured signals, no repetitive beacons, nothing that indicated an artificial origin was detected coming from 3I Atlas itself. The object is confirmed as natural, composed of ice, rock, and dust, behaving just like a very fast, very large, but ultimately ordinary comet.
That distinction is crucial then. We are not talking about some kind of alien message being beamed at us. We are talking about the physical consequence of its movement through space, a natural ringing, an exotic physics interaction.
Exactly. The 25 Hz signal is not a communicative transmission from the object. It is almost certainly a resonance caused by the object's passage. It's a physical consequence of its electromagnetic interaction with the local heliospheric plasma, which in turn perturbed Earth's already metastable and highly stressed system. It's natural, but it's also incredibly dramatic physics.
All right, so let's pivot from space now down to the ground. Let's look at the forensic evidence that the signal itself provides. The primary detection happened at the Tomsk Space Observing System in Siberia. This facility is critical to the story because it operates these high-sensitivity induction magnetometers, and it's located at a high latitude, 56.4 degrees north.
And that location makes it a perfect listening post, doesn't it? If the perturbation came from space, the Earth's own magnetic field acts like a funnel. It channels that energy most efficiently into the polar and high-latitude regions. That makes Siberia a fantastic place to hear any kind of magnetospheric input.
Exactly. But what really sets this signal apart, aside from the impeccable timing, is its spectral purity. The source material keeps describing it as a hard line.
Okay, let's stop on that jargon for a moment. What exactly does a hard line tell us about the nature of the energy source?
It tells us that the signal has an incredibly narrow bandwidth, and this is the crucial differentiator from common everyday noise. Imagine you're looking at a spectrogram. It's a visual map of frequencies over time. Common atmospheric noise, like lightning strikes, which scientists call spherics, they appear as these big vertical streaks. They're broadband, meaning the energy is released almost instantaneously across a wide range of frequencies, maybe from 3 Hz up to 40 Hz. It sounds like static or crackling. A hard line, like the 25 Hz anomaly, means the energy is concentrated almost entirely at a single stable frequency. This implies a highly stable, oscillating or resonating source rather than a noisy explosion. Something was vibrating, and it was vibrating at precisely 25 cycles per second.
Which brings us to the frequency itself, which is so baffling. Why, 25 Hz? The Earth already has its own set of natural resonant frequencies, doesn't it?
It does. And we have to compare it to the Earth's natural electromagnetic background hum, which are the Schumann resonances. The SRs are these standing waves that form in the cavity between the Earth's surface and the conductive ionosphere, and they're constantly excited by global lightning activity. The fundamental, the most famous one, is at 7.83 hertz. The subsequent harmonics are roughly 14.3 hertz, then 20.8 hertz, 27.3 hertz, and 33.8 hertz.
Wait a second, 25 hertz is right in the middle of two of those harmonics. If 20.8 hertz and 27.3 hertz are the natural notes the Earth is supposed to play, then 25 hertz is stuck in the silent space right between them.
It falls squarely in the quiet zone. The physics of the Earth ionosphere cavity dictates that energy usually cannot sustain itself in that gap. So for a strong, stable signal to exist and sustain itself there, overriding the global cavity geometry, it suggests it wasn't random static and it wasn't a standard global phenomenon. It points directly to a highly localized, high energy, or maybe even an externally driven resonance. It's like finding a pristine, perfectly tuned instrument ringing loudly in the part of the music spectrum where, by definition, there should only be silence.
That completely shifts the narrative. If it's stable and it's localized and it's not part of the standard global hum, we have to look for a non-standard source.
Okay.
And that brings us to the key piece of evidence, the Japan precedent from December 8.
Indeed. This was a massive M7.6 earthquake. It happened 11 days before the Tomsk detection and the 3I Atlas flyby. For years, scientists have been looking for electromagnetic precursors to earthquakes, but the data has often been messy or, inconclusive.
But in the analysis that followed the Japan event, they found something very, very distinct.
They found that a similar 25 hertz electromagnetic disturbance was clearly present in the geophysical data for days preceding the seismic rupture in that specific fault region. This wasn't something they detected in real time. It came through rigorous post-event analysis of the data logs.
So let's just synthesize this for a second. The exact same frequency appeared days before a huge earthquake, signaling tectonic stress, and then appeared again 11 days later, precisely triggered by a cosmic object 270 million kilometers away.
This correlation is the absolute hinge upon which the entire convergence swings. It establishes a pattern. It moves the finding from being just a statistical oddity to being an identifiable physical signature. It suggests that 25 hertz is a characteristic frequency of the Earth's lithospheric stress system. Specifically, it is the particular fault pitch or resonant frequency of certain large blocks of continental crust when they are nearing their breaking point.
And if we connect that to the bigger picture, the recurrence of 25 hertz in two completely different contexts, as a seismic precursor and as a cosmic flyby trigger, it suggests it's an intrinsic signature of planetary stress. This forces us to define a whole new field, actionable precursor science.
And we absolutely have to acknowledge that this pattern was not spotted by some human analyst furiously scrolling through data logs. This was largely driven by artificial intelligence.
That's a fascinating element of the story.
Yeah.
Why was AI the essential observer here? Could a human not have made that correlation?
Well, it's fundamentally a big data problem. We're talking about terabytes of spectral data being generated daily by global monitoring networks. A human can search for a known frequency like the 7.83 hertz fundamental mode, that's easy, but asking a human to spot a statistically improbable pristine spike at an unexpected frequency like 25 hertz and then correlate its precise timestamp with the trajectory of an object 1.8 AU away. It's logistically impossible within any kind of reasonable time frame.
So that AI wasn't specifically looking for 25 hertz, he was looking for anomalies.
Exactly. The algorithms they used were likely based on very sophisticated machine learning models, things like convolutional neural networks or CNNs, maybe even autoencoders, that are adapted for complex time series analysis. These systems are trained on decades of normal background data, the constant hum of the Schumann resonances, the solar wind variations, the usual noise profile of the planet.
So essentially, they learn what the Earth usually sounds like.
And anything that deviates significantly from that learned norm, especially a stable, high-energy spike in a known quiet zone, gets flagged as a statistical improbability. The AI flagged the clean 25 hertz spike because its purity and its stability were highly anomalous relative to the surrounding noise floor. The algorithm didn't know about 3ILS, but it found the signal, and then human analysts made the final, terrifying correlation. It validates the power of this hybrid human-machine collaboration in solving planetary-scale anomaly resolution. AI can find the needle in the haystack, but humans still have to determine if that needle is a weapon or a warning.
Okay, so we've established that 25 hertz is the frequency of planetary distress, and we have a cosmic trigger. Now we need the engine. How does a rock, deep underground, generate an electromagnetic signal that's strong enough to be detected thousands of kilometers away in Siberia? And how could a plasma weight 270 million kilometers away possibly provide the final, fatal trigger?
To answer that, we turn to the mechanism of lithosphere-atmosphere-ionosphere coupling, or LAIC, and the fundamental physics of piezoelectricity. This is the step-by-step process of how immense mechanical stress transforms into a planet-wide electromagnetic signal, something that often manifests visually as earthquake light.
Okay, let's break down the engine step by step. Piezoelectricity.
The material itself is everything. The Earth's crust, particularly the granitic continental plates that are common in seismically active fault zones, contains vast amounts of quartz silicon dioxide. Quartz is naturally occurring, and crucially, it is a piezoelectric crystal.
Which means?
When the crystal lattice of quartz is mechanically deformed by extreme pressure, the positive and negative charge centers within its structural shift. This charge separation creates an electric dipole.
And we're talking about the immense pressures that lead up to an earthquake.
Gigapascals of pressure. Before an earthquake, the fault zone is locked and the tectonic plates are building up this incredible pressure in what's known as the nucleation phase. As the rocks are compressed, they don't just fracture, they generate an extraordinary density of free charge carriers. Research models often refer to these as positive holes, mobile positive charges that can flow through the stressed rock mass. This flow creates massive underground electrical rivers, or telluric currents.
So the compression of the rock effectively turns the fault zone, which might span hundreds of kilometers, into a giant subterranean high-voltage battery. The deeper the stress, the greater the charge.
Precisely. Now for the escape mechanism. When these powerful telluric currents reach the surface of the Earth, they generate a huge vertical electric field. This field is strong enough to actually ionize the air molecules directly above the ground.
Wait, ionize the air? You mean like static electricity or a localized electrical storm?
More extreme than just static. It modifies the conductivity of the entire atmospheric column above the stressed region. This modified, highly conductive column stretches all the way up to the ionosphere, between 60 to 100 kilometers in altitude, and it drastically perturbs the global electric circuit. This perturbation then acts like a giant antenna, broadcasting extremely low frequency, or ELF, waves at the characteristic frequency of the mechanical oscillation of the fault, the frequency of the stress itself, 25 hertz.
That is an incredible, almost Rube Goldberg-like sequence. So, geological pressure creates electricity. That electricity zaps the air above the fault line, and that zapped air conducts and broadcasts the 25 hertz signal thousands of kilometers across the globe.
And this isn't just a theory. The source material details the granite boulder experiment. Researchers took a 7 metric ton granite boulder and induced stress on it in the lab, essentially simulating a locked fault zone using expanding concrete.
What did they find?
They recorded significant surface charge buildup, distinct magnetic pulsations, and dramatic changes in air conductivity 5 hours before the boulder finally fractured. Crucially, those magnetic pulsations they observed in the lab resemble actual field data that had been recorded from real-world earthquakes. It validates the entire macrophysics of LAIC. The 25 hertz signal was the physical sound of the Earth's crust groaning under strain, electromagnetically amplified for the whole world to hear.
Which brings us back to that critical question. Why is the distress signal always centered around 25 hertz?
Well, the research is surprisingly consistent across various global seismic events. Studies following major quakes like the Chichi earthquake in Taiwan and specific seismic sequences in Greece consistently indicate that the 20 to 30 hertz band is a kind of sweet spot for seismic precursors. Scientists like Hayakawa and his colleagues, they detected clear, sustained intensity increases around 25 hertz before the Chichi event.
So this band represents the natural resonant frequency of a large block of crust when it's reaching its critical instability, its breaking point.
Yes. The geometry of large fault blocks, coupled with the variations in electrical conductivity that are created by the earthquake preparation zone, it creates a local resonance that deviates sharply from the global Schumann resonances. The crust, under immense pressure, essentially has a preferred frequency of vibration 25 hertz when it's about to fail.
Okay, so we have the immense cause, which is the stressed rock, and we have the signature frequency, 25 hertz. But we still have to reconcile the cosmic event, the trigger hypothesis. Did 3 Eyeless actually provide the immense energy that was needed to cause the signal?
Absolutely not. And this is where the analogy of metastability is so essential. The core principle of the convergence is that 3I Atlas was merely the trigger, not the energy source. Think of a heavy snowpack on a mountain slope. It's absolutely saturated with latent gravitational potential energy. It's ready to avalanche. A shouting skier, a weak acoustic input, does not provide the energy for the avalanche. Gravity does. The skier only provides the trigger, the tiny perturbation that destabilizes the metastable system.
And in our scenario, the Earth's crust was the snowpack. It was already stressed, it was fractured, and it was highly electrically charged following that Japan quake just 11 days prior. It was ready to fall.
Precisely. On December 19th, the 3I Atlas plasma wake acted as the shouting skier. The trigger sequence flows perfectly from there. First, the object's magnetic weight carrying those alpha waves perturbed the Earth's magnetosphere. Second, this sudden, tiny magnetic perturbation induced slight electrical currents in the ionosphere and the ground. That's a consequence of fundamental physics, Faraday's law of induction.
Okay, but if the energy transfer is so efficient, why don't we see earthquakes every time there's a major solar flare or coronal mass ejection, a CME? What made this specific magnetic push so special?
That is the crucial, challenging question. A CME is a massive broadband magnetic explosion. It's a lot of noise, very little precision. 3I Atlas's wake, however, was a highly structured, coherent, rapidly moving magnetic signature. And critically, its magnetic perturbation was perfectly timed to hit a region, the Pacific Ring of Fire, that was already critically charged and metastable from the preceding Japan quake. The weak induced currents from the flyby flow directly through those already highly stressed electrically active fault zones.
So those minimal induced currents were just the last straw.
They provided the precise minimal electrical input that was necessary to disrupt the friction or the pore pressure equilibrium in that metastable fault zone. That small disruption caused the fault system to vibrate at its natural characteristic frequency, 25 Hz, releasing the colossal contained piezoelectric pulse that was detected in Tomsk. The energy was already there. 3I Atlas simply pulled the plug.
And this beautifully resolves the gravitational non-factor. Skeptics who correctly argue that 1.8 AU is too far for gravity entirely miss the point that the trigger operates via magnetic connectivity, not via mass.
Right. Gravity falls off rapidly. But the magnetic structures in the solar wind, they act as these continuous, highly efficient highways, especially when the Earth is already prepared to resonate. The fact that it was detected at a high-latitude facility like Tomsk confirms the magnetospheric coupling, where that space-based energy is funneled down toward the polar regions. The Earth was ripe, and 3I Atlas gave it the gentle electromagnetic push it needed to scream at 25 Hz.
So we've established this complex loop of physics that connects the interstellar object to our planet's crust. Now let's bring it down to our level. What does this all mean for us, the people living on the surface of this high-Q resonant planet? This frequency isn't just geological, it is startlingly, intimately biological.
That is perhaps the most compelling and potentially concerning implication of the convergence. The 25 Hz frequency falls directly into the human brain's electrical rhythm, as measured by electroencephalography, or EEG.
Can you give us the neurophysiological context here? Where exactly does 25 Hz land in our map of brainwaves?
It lands squarely in the high beta band, which typically ranges from about 12 to 30 Hz. To put that in context, when we look at brain activity, the slower alpha waves from 8 to 12 Hz, they're associated with deep relaxation and quiet focus, the state you might reach during meditation. Gamma waves, which are 30 Hz and up, are linked to peak cognitive processing and complex problem solving.
But the high beta band, where 25 Hz resides, that's universally associated with intense alertness, active concentration, vigilance, and the classic fight-or-flight stress response.
Precisely. A global electromagnetic field oscillating at 25 Hz is resonating at the exact frequency of human psychological tension in preparation for action. And this immediately raises the critical possibility of brainwave entrainment, also known as the frequency-following response.
Right, we see this with light and sound things, like binaural beats, flashing lights, where the brain starts to synchronize with an external rhythm. But can an extremely low frequency, an ELF electromagnetic field, like the one detected in Tomsk, actually affect human biology? The power must have been tiny.
The field strength detected was likely very, very low, certainly well below the established thermal damage thresholds that are defined by organizations like the World Health Organization, the WHO. However, we have to consider the effects of weak field interactions, which don't rely on heating tissue. The concept of stochastic resonance is key here.
I'm going to need a simpler way to understand stochastic resonance, because that sounds like advanced physics trying to justify something that sounds, well, almost magical.
It's not magic, it's signal processing in a noisy system. Imagine you are trying to tune an old analog radio to a very weak distant station. If the room is totally silent, the signal might be too weak to hear over the radio's own internal static. But if you add a tiny optimal amount of white noise to the room, just the right amount, that background noise can actually help the weak signal lock onto the receiver better, amplifying it above the overall noise floor.
Ah, so adding a little bit of chaos actually helps the biological system detect a signal that was otherwise invisible.
Exactly. Biological systems, being complex and inherently noisy, our neurons are always firing randomly, can use that internal noise to amplify and detect signals that would otherwise be ignored. So the Earth's 25 Hz scream, even if it was low intensity, could have been detected and internalized by the neural networks of a globally distributed population.
The potential subjective experience is profound then. If a global population is subliminally entrained to a 25 Hz high beta signal, the collective cognition might experience a sudden, inexplicable wave of tension, hyperalertness, or even widespread insomnia, the Earth's distress signal being felt as global anxiety.
It would manifest as a collective physical uneasiness without any discernible cause, what some of the source materials call the global anxiety phenomenon. We know that following December 19, there were anecdotal spikes in reported sleep disturbances and generalized stress indicators worldwide. Now, correlation is not causation, but the mechanism is suddenly plausible.
That brings a fascinating scientific validation to the popular notion of animal precursors. For centuries, people have observed animals, dogs, birds, deep-sea fish exhibiting panic or unusual behavior hours or even days before a major earthquake.
Right. If the earthquake preparation zone is generating a powerful 25 Hz piezoelectric pulse, a physical, quantifiable, anxiety-inducing ELF field, then the animal panic isn't precognition. It's a physiological reaction to the sudden onset of an environmental field that is specifically tuned to the high beta band of their nervous systems. Animals, which are often more finely tuned to environmental changes than humans, are literally sensing the planet's distress long before the tectonic plates actually slip.
And we should, of course, address the possibility of man-made interference before we wrap this up. Could the 25 Hz signal have been a simple industrial artifact, like from electrical power mains?
The scientific panel rigorously addressed this. In Russia, power grids operate at 50 Hz, and 25 Hz is a potential subharmonic of that. However, the Tomsk station uses advanced filtering systems, and a typical grid fault creates broadband noise, not the pristine continuous wave that they recorded. The definitive counter-argument, though, is the precise time correlation. The signal spiked exactly 3 hours and 20 minutes before 3i Atlas reached perigee. A random industrial accident simply does not correlate with an astronomical event 270 million kilometers away. The evidence is overwhelming. The signal is geological and cosmic, not infrastructural.
So the December 19, 2025 event is more than just a fascinating coincidence. It signals a definitive forced shift in methodology for Earth science. We are entering the era of multi-messenger geophysics, where we can no longer afford to only look down to understand tectonic events. We have to integrate our understanding of space weather and electromagnetic coupling.
And central to this shift is the validated role of AI as the primary observer. The fact that an AI flagged the correlation is the single most important methodological advance to come out of this entire thing.
Absolutely. The sheer volume of geophysical data that's flowing in real-time terabytes every single day. It means only AI algorithms are capable of flagging statistically improbable events like that clean 25 Hz spike. This validates the utility of AI in precursor science, the ability to mine the noise, find the subtle patterns, and identify these nonlinear correlations that can foreshadow catastrophic future risks.
And this shift takes us away from the holy grail of exact earthquake prediction, specifying the precise minute and location, which remains frustratingly elusive, and moves us toward the viability of risk assessment.
The 25 Hz anomaly offers a concrete roadmap for just that, for risk assessment. If we establish a global network of AI-monitored stations that are constantly listening for 25 Hz, a widespread, sustained rise in that activity would indicate that the lithosphere is entering a critical metanstable state. Then you combine this terrestrial stress data with heliophysical data, solar wind speed, coronal mass ejections, or approaching magnetic disturbances like 3i Atlas's wake, we can begin to develop a true space weather forecast for earthquakes.
That is a powerful new tool. It would allow us to manage and prepare for risk, even if we can't pinpoint the exact moment of rupture.
And future systems will almost certainly utilize federated learning. This is a cooperative AI model, where specialized algorithms on satellites like China's CSES-01, which monitors the ionosphere, and ground stations like Tomsk, can share insights and patterns in real time without ever sharing the raw data. So if Tomsk hears a scream, a 25 Hz spike, the AI can instantly cue the satellite to specifically focus its ionosphere density monitoring efforts over known, stressed fault lines in regions like the Pacific Ring of Fire. This is proactive, machine-driven risk management.
So the final synthesis is clear. The 25 Hz anomaly was not an alien message, nor was it a simple gravitational interaction, which is what the skeptics initially claimed.
It was a precise piezoelectric cry from the Earth, induced by the electromagnetic wake of a cosmic passerby 270 million kilometers away. It confirms that the Earth is not decoupled from the cosmos, but is actually a sensitive, resonant system that's intimately coupled to the broader heliosphere via magnetic fields. It validates the trigger hypothesis, showing that in metastable systems, the butterfly effect is real and it operates via efficient magnetic connections, not mass. We just have to learn to tune our instruments and our algorithms to the right frequency.
And that leads us to the final provocative thought for you to mull over as you process this deep dive. The Earth's crust, groaning under tectonic stress, generates the same precise frequency, 25 Hz, that triggers human alertness, anxiety, and the primal fight-or-flight response in our brains. Could the planet's distress signal be literally our own psychological state amplified? The planet is not silent. Perhaps we just need to accept that its voice sounds exactly like our collective subconscious panic.